Cool. So, some of you know me, some of you may not. My name is Jeev. I'm a software engineer at Freenome. And this talk has been a long time coming. We adopted Freenome almost like over a year ago, and I'm very privileged to be able to give this talk today, just to kind of showcase like how we use Flyte at Freenome, and some of the interesting things that we think we've built over the last year. All right, let's see if we can figure this out. I've never given a talk on Zoom. All right, so quick agenda. We'll talk a little bit about who Freenome is and hello Flyte, so where Freenome actually meets Flyte. And I want to introduce this concept, or we'll talk a little bit about this concept of reactive workflows with Tower. I know that somebody that actually had a blog post kind of related to this. I want to flesh it out a little bit more, and then we'll leave some time at the end for questions. So who is Freenome? So Freenome is actually a very cross-functional team of molecular biologists, computational biologists, machine learning engineers, software engineers, like medical industry, health tech veterans, regulatory professionals, so on and so forth. And we're here to build next generation blood tests for early cancer detection. And why early detection, you may ask? So to direct you to this chart on the right here, on the x-axis, we have a bunch of different cancer types. On the y-axis, we have survival rates. The black bars indicate like localized cancer, and the yellow bars indicate like metastatic cancer. And what's apparent from this chart is that once your cancer metastasizes, your survival rates actually drop significantly across multiple cancer types. So if we're going to have an impact via intervention, we want to detect cancer early when it's still localized and not metastatic, right? And so how do we do this? And so this is actually a pretty hard problem because if you want to detect cancer early, the signal is very, very low, right? Because there's a small amount of cancer signal in like basically drowned out by a whole bunch of healthy signal. And so the approach that we take, and there's a number of companies that are actually like working on this problem, but like the thing that makes us stand out, I think, is that we are taking a multi-omic approach combined with machine learning. And I say multi-omic because we're actually looking at more than a single biological molecule. We're attempting to like characterize, quantify, and extract biomarkers from like many different types of biological molecules, including proteins and DNA and more. And this helps paint a really clear picture of a patient so that we can then use this information to apply our machine learning and make a call about whether this patient has a cancer signal or not. And the really exciting part about this is that like we can actually do this from a routine blood draw. And so no complicated testing procedures, like no, like days or weeks or whatever in the lab or anything like that. You can walk into your doctor's office, as part of a physical, or walk into a lab, get your blood drawn, and actually have this test administered. Super exciting. And where does Flyte fit into all of this? I mean, we're trying to do something important, and a lot of it is like really running workflows. And I want to share some of the places where we use Flyte in this entire platform. So I actually thought I would start with a quick summary of like how we're using Flyte at Freenome before we dig into why we chose Flyte. And so we are a biotech company, and so there's a lot of data flow, there's a lot of bioinformatics. We're also a machine learning company, so it's a lot of feature engineering and machine learning. And so everything from like pushing data from our production systems into research, right, where data scientists can then operate on it, extracting data from external sources into our internal data stores, running bioinformatics, really complex, large, and heavy bioinformatics workflows on data coming out of our wet lab that our molecular biologists are generating, like processing data from external sources. There's a wealth of public data available, using that to like learn more about like what the hallmarks of cancer are and so on and so forth. Pre-processing our molecular data into a form that we can run feature engineering on, like generate features. And then run machine learning, right? So like hyperparameter optimization, training and inference. And then a small subset of all the work that we've done in research up to this point, makes its way into our product pipeline. And that's where like, we're actually running against real test orders. And so Flyte, as it turns out, as you can see, like, there's this weave through many of these components. Like Flyte actually is used in every single one of these different components. So it's like across our entire data engineering and data science stacks. And so it's not an understatement to say that Flyte is really a workhorse at Freenome. And so, this is something that we've actually built or set up and had going over the course of the last year. And I think that we've invested a lot in in things like a sandbox, right? Like the stuff that that's available in Flyte Cuddle Sandbox, in templates and stuff, like basically inspired by the work that Union has done, inspired by the work that LatchBio have done. And we really wanted to get Flyte adopted quickly across the organization. But most importantly, I think Flyte made sense from many different perspectives at Freenome, and so I think that really drove adoption at Freenome. So I want to talk a little bit about why we chose Flyte at Freenome, and hopefully, as a biotech company, right, why we chose Flyte, and hopefully that inspires other biotech companies to also consider Flyte to run their stack. So why Flyte? We're a Kubernetes shop. Like all of our workflows, everything runs on Kubernetes. Kubernetes is basically ubiquitous now. It's all over the place, and it's making the running workloads and operating and monitoring cloud workloads really easy. And so one of the important things that we wanted was a Kubernetes native workflow engine. And there's actually less than a handful of them around, and Flyte was one of them. The important thing for us was also that we needed a workflow engine like this, since it's so core to the stuff that we do at Freenome. We wanted it to have a sense of credibility, to be battle tested and so on and so forth. And so Flyte was developed at Lyft by Caden's team, and at Lyft it was running more than 1 million workflows per month across 500 users. And Lyft has a really rich history of open source software, including I guess Envoy and Amundsen and so on and so forth. So we felt very good about adopting technology coming out of Lyft this way. It has an extensible plugin system. This was really important for us. We're running most of our workloads on Kubernetes right now, but Flyte is really execution engine agnostic. And so and if you wanted to run Spark workloads, if you wanted to run PyTorch workloads, or whatever else, AWS Batch or Google AI Platform or something like that, we can basically write a plugin that would work. And most of these plugins already exist, but it allows us to grow, right? As our needs evolve, we can still keep the very basic UX for our users, and then run on all these different engines that have their own pros and cons and so on and so forth. So that was really nice for us. It already has an SDK in Python, so that's less work that we had to do. And it's a great SDK. FlyteKit has been amazing. There's been a lot of development on it, and we're very excited to use it. We're using it basically everywhere at Freenome right now. It's fully open source. It was open source at KubeCon. And sorry, I should have updated this slide. It's a graduated project in Linux Foundation AI and Data Umbrella, not incubating anymore. So that lends even more credibility. And so as a biotech company attempting to get FDA validation for our product, here are all the things that we can say that we can use to defend our decision to go with Flyte. And then most importantly, an open source project is not really great without a really strong community. Things like getting PRs approved and getting help and support and things like that has been really seamless within the Flyte community. So we have a lot of power users here. We have Lyft, Spotify, Gojek, Woven Planet, LatchBio, Merantix, so on and so forth. I missed a whole bunch, but they're on the Flyte website. And everyone has been super helpful and has really helped us supercharge our adoption. So we're very grateful for that. So a little bit to dive into some of the features that we really care about Flyte. I know that maybe this audience has seen this so many times, but maybe it's a good thing to just kind of reiterate why this is very useful for us. So it's Python, right? I mentioned earlier that we're a cross-functional company. We've got molecular biologists, computational biologists, and so on and so forth. So we've got a wide range of engineering capabilities, and we want everyone to be able to feel empowered to use Flyte. And so having having to write a Python function to run workloads on Flyte is really, really nice for us. And the beauty of this is that you can run it locally. So it's just running a Python function and then just ship that remotely and run that at scale on the cluster. And that's really nice as well. And in biotech and probably in other places as well. I think with anything related to machine learning, reproducibility is like a huge thing. And it's like really important for us because we want to be able to defend like, certain life-changing calls that we make for our patients. And Flyte has this concept of like an immutable transformation, right? Where they're running within like, tasks are running within these like containerized environments, and they're versioned. And as it turns out, they cannot be deleted. And so like having this like immutable transformation is a really nice abstraction to have for our data engineering stack. Bioinformatics workflows also tend to be very heavy and very expensive. And so, you don't want to run the same tasks with the same inputs like multiple times. And so Flyte allows us to basically memorize and cache the output just by introducing like, like you see here, a cache argument to the task decorator. It helps us overload. It allows us to override like resources. We might have a simple like cheap task, and we might have like a really expensive like alignment task, right? And all of them can run within the same workflow just by specifying these. As it turns out, you can also override these like at runtime as well. And so like if the workflow sees a really large file, like it can basically adjust its resource requirements like on the fly for the child tasks that need to run. So that's been really nice for us as well. And given the scale at which like some of these tasks run, like, it can get really expensive in terms of compute. And so just being able to like add, an interruptible argument to the task decorator for certain tasks has been really useful in like, cutting back our costs a little bit as well. So some really nice features coming out of the box, like batteries included with Flyte. So that was really nice to have. And this concept of extending tasks, right? So like we talked about writing like plugins earlier. And you can also write like Python plugins, right? Like Python tasks as a way to kind of like extend the Flyte SDK a little bit. And so here I show an example of a SQL alchemy task, but like for bioinformatics, you can easily have like, an alignment task or a variant call-in task and stuff like that, where you just wrap internally the logic associated with passing like parameters to like, an aligner of your choice or a variant call of your choice and stuff like that. So since it's just Python, it's really nice to build. It's really easy to build like these abstractions, right, on top of the underlying binary or tool that you're using. And this makes it very easy for reusability. So like other teams can just pick up and they don't have to like figure out this underlying alignment tool. Like they can just work off of this, this custom task. Workflows. So, I mean, obviously this is a workflow engine. And like, we want to be able to string together these tasks in a way that makes sense. And the beauty of what Flyte gives us is that like type validation occurs at registration time. So we are guaranteed that the tasks are going to play well with each other when we're registering the workflows. So that's really nice. Sub workflows. This is something that we were very excited about. And so, again, with reusability and trying to keep code dry, being able to like share workflows within, Python libraries. And even better, I think, is that we're actually able to like call into reference workloads that are not even part of your project. That have been like pre-registered with Flyte and actually run things like, featureization or whatever, right, from like within your own project. So there's a lot of room to really share the work that you've done, that your team has done in terms of writing workflows with like other teams and stuff like that. So it really increases like room for collaboration and stuff. And we really love that at Freenome. Dynamic sub workflows. This, I think, is probably one of the most important features for us. There's actually not very many workflow engines that can do this. And so this was like, this was a big deal for us, basically. And so, with bioinformatics, you can have like files in the order of like terabytes sometimes. And, one thing, simple operation that you might want to do on this is essentially like to chunk this file up into smaller pieces, process them in parallel, and then aggregate the results at the end. And so, a feature like dynamic tasks like helps us do that really, really seamlessly without like having to, add crazy hacks. Right. So, and here's an example of like a simple like chunking of some inputs, running it, and then returning some values that can be aggregated later. So fan in, fan out type workflows, very common in bioinformatics, and we really appreciate this feature. So coming back to like, this diagram that I shared earlier, right? So like there are all these like features in Flyte that made a lot of sense for us at Freenome, and like using Flyte in like research organizations, so like research in the research context has been like really talked about a lot. I think, with respect to like feature engineering and machine learning, there's a lot of examples that have been shown. I want to talk a little bit about like running Flyte as part of a product pipeline, because that's not something that has like traditionally been talked about at this meeting. And I wanted to introduce like the concept of reactive workflows in the context of like running Flyte in as part of our product pipeline, because when we're running it in like production, there's not going to be a human pushing buttons. Like nobody's like firing off workflows. Nobody's like pushing play or anything like that. Things just kind of need to happen, right? Like files drop, things need to happen. Messages get received, things need to happen. Schedule, cron trigger, things need to happen, and so on and so forth. And so we wanted a completely like no human in the loop, like hands-free approach to running like all of our our Flyte workflows that we're running as part of our product pipelines. And so we talked a little bit about this in the past, but we actually built a small framework, a light layer around Flyte that helps us essentially like orchestrate these reactive meta workflows using Flyte. So I want to talk. I want to take a little bit of time to kind of talk about that, but also introduce this concept of like reactive workflows and the power that it has, in production, like as part of a production line, as part of this like conveyor belt that runs in production. So we built a little tool, a little wrapper called Tower, and it's basically an air traffic control tower, Flyte air traffic control tower. And so it's almost like a way that like we can orchestrate very self-contained like Flyte workflows or modular Flyte workflows into much larger meta workflows that run as like that might walk a sample through the entire product pipeline, all the way from like receiving raw inputs to generating a report for the patient. Right. So what exactly is it doing? Like, so in very simply, like Tower is basically receiving some events, either from object storage. So like when files get created or dropped or modified, from PubSub, where other services might be sending messages that might trigger Flyte workflows. Also cron schedules, and also this concept of like entity state updates. And so Flyte and Tower is basically consists of two different components. It has handlers that respond to these different events, and it has like this concept of entity, which essentially is a business like unit of work, right? And so event handlers are written to essentially process. They're basically Python functions, and they're written to like process events coming from all these different sources. And these handlers can basically create business entities or essentially transition them from one state to another. And we'll talk a little bit later about what these business entities are. And when entities are transitioned to a certain state, and in this case, like it's running, we basically like kick off Flyte workflows. And these Flyte workflows will finish, and then we'll either succeed or fail and like update the entity state accordingly. So what are entities, right? So like I said before, entities are basically business units of work. They're extensible state machines. And so, it's basically something that was kind of like copied from Flyte, right? Where like every node is essentially a state machine. This is built on top of SQL Alchemy, so it's very light. And you can basically define like, attributes and relationships to other models. And like you can define this like get job spec method that will basically kick off a specific workflow that is a workflow execution that is like composed dynamically when this thing is ready to run, essentially. So by the way, like feel free to stop at me at any point in time to ask me questions. I know this is a little off here. And artifacts, we have like a few different types of like event handlers that we're supporting. So like one is artifacts. And so like you can basically like trigger these handlers on one or multiple artifacts, and it has support for like wildcards. And so this is what the syntax kind of looks like, right? So you can like an app is basically just a Tower app, and I'll talk a little bit about that later. And then on artifacts, you can just define like multiple artifacts that you want to kind of listen on. Oops, my bad. And what the code will do is it'll extract the actual value that was passed, that was like received. It'll provide that to the handler, and also will extract these wildcards out and provide that as like adders. And so you can use this. You can use these handlers to like basically say, okay, now that my sequencing run is completed, let's kick off like a Flyte workflow that processes the sequencing run, right? And another type obviously is like messages. And so we have these message streams that we can define. So here's a message stream that basically looks for, within the payload of the message, like it looks for type equals a simple message, essentially. And then all these messages are passed to this handler, and then this handler can be used to like, create a workflow, create an entity, or basically like find an existing entity and move that into a different state. Cron jobs, this is something that we, we don't really use this a lot, but like we thought that there was some value here where we can basically like, run handlers periodically with just a simple cron syntax. And finally, this entity state updates. And so when entities, like, we talked about business entities and how there's entities of state machines. And so like, as they are transitioned into like running, right, like Flyte workflows kick off, but when they're transitioned into like, succeeded or processed, we can create we can basically run, additional handlers to maybe like extract some information about the QC, right? And then like transition this entity into like a QC pass or a QC fail state and stuff like that. So the reason why we built this, right? I think this is my last slide. I want to leave some time at the end for questions, but the reason why we built this was because our production pipeline is actually like a really, really complex one, right? So what's happening is that like we receive these blood samples. These blood samples then get like, we extract our molecules from this different sort of analytes from these blood samples. And then these analytes all basically get processed asynchronously. So they're going off into like their own track of analysis of pre-processing. And so once all of these finish, possibly at all different times, their data will land separately in GCS or in object storage, right? And so we're really kind of like kicking off independent analyses of these analytes when they arrive. But then when we're actually doing the machine learning, we need to make sure that like all of these are present, right, before we can like do some feature engineering, generate the features, and like actually pass it to our classification pipeline, and then generate the report. So there's a lot of coordination that needs to happen, and this coordination is actually like over time, right? And so this system that we've built like basically helps us do that. Like it helps us basically wait for things that need to happen, and then check to see if like all the other dependencies have been met before like, proceeding forward, and so on and so forth. So in a way, it's like almost like a workflow, right? But it's not like a static DAG. It's not like a synchronous workflow that's happening. It's like happening as the state is basically blooming as things are happening, right? And this is what I think like this was a very important piece of like driving our product pipeline. And again, this is not like final, right? Like this is our first iteration at taking an attempt at reactive workflows. And so we wanted to introduce this as a concept and bring this to the community and see if like we can have an actual like a community-driven effort, an open source effort to build something that can support use cases like this moving forward. And so we've built it obviously now as like kind of like a Django app-ish type framework, right? Where like we have models and handlers instead of like models and views. But an argument can be made that like this can be built into Flyte, and Flyte has the ability to kind of like watch for events and respond to like a workflow, which is already a concept that exists in Flyte, right? So like there's a lot of room, I think, to work on this concept, reactive meta workflows. So that's all I have. I want to leave some time to take questions. So opening it up to the floor.
Yes, fantastic work with Tower. Are you guys going to open source it, or?
So that is still kind of like up in the air. We are considering it, but we haven't like taken any concrete steps towards this. But like we can talk about it. Like we can talk about it in the context of a larger community and see if it makes sense. Right now, it's built very, very specifically for us, right? Like we didn't want to over-engineer it, so it's like GCS only. It only works with PubSub and GCS, and so it's very specific. But like we can talk about what it takes to maybe make it open source, and maybe just start a discussion about like how we can build something better for reactive meta workflows. Because ideally, like we don't want to be solving these problems. This can be solved at the platform level, and it could be useful for like many people.
I actually think it doesn't need to be part of Flyte. It can be something that works with Flyte within the ecosystem, right? Like I think one of the things I have learned over a period is to keep this app as small as possible. Like you can keep on expanding, and then our surface area to break other use cases kind of increases. But that doesn't mean, I think we would love to support Freenome in any way if they want to open source this under their umbrella. Don't even think about over engineering. Think about like, getting GCS and Google Cloud support done. And I think the community here is awesome enough that other things will just land in if if there is if it is open. So
Yeah,
and
for
we
sure.
would love to support it, right, on the Flyte orgs ecosystem. I don't know if you guys have seen that. There's a new ecosystem tab where we are adding projects as they're getting created across the different companies. So
Cool. Yeah, I haven't looked at that yet, but that sounds exciting. So, I mean, we basically built this on top of Flyte Remote. So, you know, it's like it's a light layer on top of FlyteKit that's working really well for us right now. But yeah, this could be exciting to.
yeah, that's what Union ML is also. It's just a light layer
Gotcha.
on top of FlightKit. But I think the point of view matters, to be honest, right? And the use cases matter. So when you build an open source tool that's extremely lightweight, it has a larger adoption, right? To be honest. So we would love to help you evangelize that. Absolutely.
Cool. Let's talk. Any more questions that I can help answer? Hopefully, I don't know if there's a lot of like biotech folks here in this call, but maybe this video will make it to YouTube and people watch it and they'll feel inspired to like, look at Flyte for biotech applications.
Yeah, to be honest, you guys have already like kind of, just by putting the name has helped a lot of biotech, and then Latch Bio talking about us. And yeah, biotech is probably one of the most active communities, interestingly, looking constantly at Flyte and a lot of production deployments now. So, and we hope to grow that even further. So this will really help. Thank you.
Awesome. So it sounds like everybody thought this was an awesome talk and there's no questions. So I'll stop sharing. Thanks, everyone.
The talk was awesome. The recording will be published later today, but anybody have questions, don't be shy, ask them.
Yeah, or feel free to reach out on Flyte Select. We're here. There's actually quite a few Freenome folks on the call right now as well.
If you don't mind me asking, how many Flyte clusters do you have? You manage, it's like, I guess just for other people who don't know, you guys manage clusters separately, right? Like you don't use the multiple domain primitives within Flyte, you just manage them separately.
Yeah, so I mean, this was our initial talk, but like we're hoping that we'll have a few more talks to give that like dives into some more of these things. But briefly, yeah, so we run a single Flyte cluster, a single Flyte deployment per GKE cluster. And so like we don't have even staging. Staging is like a separate cluster with a separate Flyte deployment and so on and so forth. So that's how we kind of run it right now. But we like the flexibility of saying like having a centralized control plane with multi clusters. We're just not using it right now. We're also, the other thing that we're also kind of doing differently is that like we are pre-creating like all of our projects with the right permissions and the right infrastructure and things like that. And with features like pod templates and stuff, that really helps us like really platformize our platform, I guess. So it's very like it's a very tight ship, I guess, is how we're running on Flyte deployment. It's not like people are just not creating their own projects with whatever and like running things there. And so far it's been working for us, but it'll be interesting to see like how this model evolves as we continue to scale.
Hey, Chief, this is Martin. I have a quick question for you, maybe a little bit of advice that you can give for new users potentially watching this on YouTube later. What would you recommend them to do, when they get started with Flyte? What's your number one tip how to get started with Flyte? That's a tough one.
I mean, well, this is actually not that difficult for me. I mean, we like talked about this a long time ago. I think we like the first thing that Freenome did, that I did at Freenome while like introducing Flyte to internally, as well as like also in concert with like Caitlin and Haitham, is to introduce this like sandbox, right? Like give people a really easy playground to like start playing around with, like throw some examples in there and essentially like let them play around with things. I think that's the best way to like adopt it and learn the features. And you can always come back to the sandbox, like if you need to reproduce a bug or if you need to like, revisit or like dive deeper into a specific feature and stuff like that. And so that playground actually, like it pays off over and over again. And so I would say like the first thing you need to do to get started, like don't even bother with like getting all the deployments up and going. Like I would say just get a sandbox up and running, get familiar with the API, get comfortable, test the features out, see the, look at the features that make sense to you, and then take it from there. And that's what we did. Yeah.
Thanks.
You're welcome. All right, Joel. Signing off here.